Let's start by talking about where all this stuff comes from, right? We're going to be talking about Gen AI and predictive maintenance, but what's the beginning? Let's talk about data. John, can you tell me, in short, a bit about the data that we use, condition data? What is it? Where do we find it?
Yeah, absolutely. So at the core of predictive maintenance, or predictive maintenance by Senseye at least, is condition monitoring data. So this comes in the form of vibration, temperature, speed, flow, pressure, cycle time, current analysis, and a full range of other sources of data. But really, that is the data that we have. The core of that is condition monitoring. So essentially, if you think about it, condition monitoring in a traditional sense, like what I used to do, required a human being to go around and take manual measurements from assets, whether that was vibration or running thermographic scans or whatever it may be. And then a human, the condition monitoring engineer, would have to analyze that data, upload it to the computer, analyze it, look for any anomalies or trends within that, and then report back on that. Whereas the data we use for predictive maintenance is online.
Okay, so that's condition monitoring. That's getting data that you monitoring. So what's a condition-based maintenance program?
Essentially, using that data. So once your condition monitoring engineer or technician has gathered the data, analyzed it manually, reported back on these trends or anomalies that they've found based off of their time-based and typically route-based approach, they would then send that to the maintenance team. So, for example, we used to have when I was doing it on site, my past facility we were working in was a chemical factory. We would email the reports through to the maintenance team. Right. And most often they wouldn't really look at it. They're busy people. May check the emails once a week. And that would then require us to go to the workshop and say, hey guys, have you had a chance to look at the reports? Have you looked at the emails we've been sending? And we would nudge them through. But condition-based maintenance is using that information. It's performing maintenance not on your time-based approach, but on the information of the asset's condition, and which have highlighted signs of degradation.
Okay, so this is the first steps in moving away from reactive or run to failure, etc. You're using some data to make an assertion about something to do with an asset that needs some maintenance, but in real time.
Yeah, but it was also, you would look at for vibration analysis, for example. If a company had a very robust program in place, that was one measurement a month. If you happen to catch the asset or the machine while it was running, because quite often the asset was in standby, or they were performing maintenance, or production wasn't there, so the production requirement wasn't there. So you would have to skip over it this month and try to get it on your next route back. So it was the information that you're working on was very spread out in the grand scheme of things.
Okay. So useful, but potentially unscalable, time intensive, etc. So let's move on then, because we want to hasten on to Gen AI. But before we do, tell me then about predictive maintenance. We both joined in order to go and evangelize about predictive maintenance, which is the next onion there on top of condition monitoring. What is it? What should it be?
Yeah, essentially it is an evolution from traditional condition monitoring. So it is using online condition monitoring data. Again, some examples of this is pressure, current, torque, vibration, temperature, speed, flow, cycle time, electrical quality, and so on, but online. So you're monitoring this not in real time, but near real time. So instead of having a sample once every month or 2 months, you're looking at samples every minute, every second, depending on the complexity of the asset. But along with that, it requires operational data so that the machine learning, the predictive maintenance solution, can understand the context of the machine. Is it running faster than it was previously? Do you have a different batch running through the line that needs to be taken into consideration? So it's taking that in and it's building an understanding of normal behavior and then alerting to abnormal behavior. So highlighting those signs of degradation based on a change of the condition monitoring data. However, like any good real-life condition monitoring engineer, it learns. It continues to understand more about patterns of failure, what they mean, what they indicate, and then how to repair them. So it is still based off of the condition monitoring techniques, But the process of data collection, analysis, reporting, and learning is now automated by technology.
Okay, so it's the same data, but it's using it to do something 24/7 that doesn't require human intervention until we say it does, and gives a richer set of insights because it's learning about those machines and making long-term assertions rather than statements about now.
Yeah,
okay.
Absolutely.
Yeah. It's probably a moment that's worth mentioning because it becomes relevant. If you go back to 2018, the reason when I came across Senseye, the reason I was so excited to come and say, please, can I work with you, is that the market was awash with companies talking about AI and machine learning, but actually not really delivering services around that. And it was more of a sort of marketing tagline. Or they've developed things related to machine learning and in the kind of world of AI, and then we're looking for a problem to solve with it. But Senseye didn't talk about AI and machine learning. It just used it to very neatly do exactly what you've just described. So it was taking a very real issue and a very real scenario within platinum mines and steelworks and chocolate factories and contact lens factories and whatever it might be, the sort of shared issues, and addressing them and actually providing a very useful solution, which excited me. I mentioned that because we don't talk much about AI and machine learning. We need to now because we need to flag what it is that's happening. We've kind of ended up neatly with this AI sandwich, if you like, because we were AI and now we're layering in AI again.
But do you remember back in the early days of us working for Senseye, we had a rule that if we used acronyms, we were doing it wrong.
Yeah,
so I remember all acronyms from our material, from our conversations, no AI, no ML, no IoT, get rid of all of it.
It's true. And if we got, I suppose there's a lesson there, isn't there? If you get drawn down the road of discussing things with acronyms to do with those things, then generally speaking, the meeting might have gone wrong. So for the audience, I think if you're scanning the market and looking for solutions and trying to understand them, try not to use that language. Try and use the language of requirement, the language of use case, the language of business case you're trying to solve. Yeah, we very much focused on the business case that we solved was reducing downtime and making people more efficient at their maintenance. There's no mention of technology. Okay, that's good. So we've set the scene. Data is conditioned data. It comes from machines, either from PLCs or from sensors or from drives, etc. And we've got various layers of complexity of what we do with that. And we've been doing that successfully and growing for a number of years now. We've had some major changes, some minor changes, but fundamentally what we do hasn't changed. But now we find ourselves in this exciting world where, and let's go into acronyms, we see large language models and generative AI and ChatGPT, which they named it something else, amongst others. There are other platforms out there available. But quite clearly, this changes the horizon, doesn't it? Because of a whole set of new capabilities. And I'd like to think that for the audience listening and for us, everybody knows what Gen AI is. But people have different. We know fundamentally in our roles that people have different understandings of what we're talking about, different expectations. So let's just talk a little bit about Gen AI. Actually, I was at a garden party on the weekend on Saturday, and I was speaking to a lovely lady who told me that Gen AI works, but if you ask it a question and you don't put a full stop at the end, it doesn't know it's a question. So I just agreed with her. I thought that's absolutely right. That's the fundamental flaw with Gen AI. But the point is, it's evolving fast, and there's all sorts of understandings and misunderstandings. So let's just take a moment to recognise the fact that probably most people have used it to write poems, limericks, to see if it can help with a Sudoku, draw a picture, etc., because they're the kind of go-to examples. But actually, what we're doing is taking the core, deep competence of Gen AI and using it to do something fundamentally exciting with our product.
Before we get into that, Ona, when ChatGPT was released to the wider public and it became this wonderful new toy that everyone was experimenting with, what were your thoughts then around what it could do for the general population, not specific to our technology, for example?
I got drawn into those conversations about how I I want Gen AI to do the washing up so I can do my art rather than do my art so I can do my washing up. But yeah, because I, like many people, got drawn down the understanding that it was, I don't know, they're the go-to use cases you come up with in your head before you've had a chance to really look at your environment. What about yours?
I don't know really. When it came out, I thought, oh, this is interesting. I can do some fancy things, and I got it to write a few songs with a country twist to it, and weird things, just testing it out. But I didn't find an actual use case in my day to day necessarily. I continued and just knew that this thing was there. However, when I did,
sorry, go on.
When I did start to use it, just to summarize meeting notes and format things that I didn't want to spend the mental capacity on. I say, I need to get across these 5 points. Write me a text in this type of style. And it would do the majority of it quite well. And I could just put in the finishing touches and save myself an hour's worth of work.
Yeah, exactly. And I hasten to add, your question was about the beginning. I now use it for all manner of tasks. Basically, it can do whatever you imagine it might be useful for it to do. I think that's the kind of point, isn't it? Whether it's summarizing notes or fact-checking the notes or giving you some ideas of next steps, whatever. There's all sorts of stuff that can happen in a day-to-day working environment. So let's do this. Let's talk a bit about this in the context of Siemens. Siemens sees generally the opportunity for advancements of various different use cases across its existing products using copilots. Siemens is a big organization and understands the responsibility required to do that properly, and has developed a number of copilots that start off with safety in mind, cybersecurity, etc., and will put up ratings to make sure that the work that's being done is relevant and kept within the confines and context of the thing you're aiming to achieve. We are one of those use cases. Our use case is about furthering the quality and the experience and the insights that you get from a predictive maintenance platform. Using all of that competency and complexity that comes from a large language model that's continuing to learn, and putting it in a responsible way into our product. Why do we do that? Why would we want to do that? What's the rather than a marketing strand, what's the first thing that we're going to say is going to be the benefit that's going to bring a client?
I guess, what is the first benefit it actually brings? That's very hard to say, because every customer, every client, every user will have different needs, requirements, problems to solve.
Yeah,
I'd say for us, one of the big things that we've seen is making information accessible. So previously, up until a few weeks ago, our landing page was really nice, gave the users all the relevant information they needed to know. But a lot of that information was based on graphs, charts, squiggly lines. And unless you have some sort of data analysis experience, it's quite hard to interpret what does that mean. And if I think back to when I first started, in fact, looking at the charts, the very first time I saw it, I had no idea what that meant. And I came from condition monitoring background. So I was in a better position to understand it, but I didn't really until I was taught what everything means, what the highlighted bits meant, and so on. But now users don't need to know anything about the charts, because the application is telling them upfront what is happening, whether there's anomalous behavior or step changes in the data or threshold violations or upwards or downwards trends.
Okay. Yeah.
So it's giving that information around the data, around the charts upfront. But it's also then able to present users with relevant information and feedback from the past. So instead of a user now having to go and look back at an entire history for an asset over 5 years since it was onboarded, it's doing that for the user. It's actually interpreting the previous patterns of failure and looking for correlations, looking for similar behavior, and presenting the user with maintenance event information that has been recorded, previous case or notification feedback. And again, it's presenting that to the user upfront, so they don't need to do any digging. It's there in written language, and in fact, any language.
Okay, so that's a really good way of describing it. I'm going to think of our distribution of different types of clients. Some of them are individuals who probably do use acronyms like AI, And they very naturally want to work with the platform, get in, start investigating, understand the logic behind it. We have other teams who are not time rich, as you say, are not necessarily data literate. They just need guidance. They need to be pointed. And, I think do you remember we always used to historically say that but this was just a platform. We wanted you to take the information out of it as quickly as possible and involve it in your decision-making processes. But I suppose now this changes that, doesn't it? Because now they have the ability to ask, discuss in natural language, and find out a bit more about the case. If they're nervous or worried about interpreting it, they can express that nervousness and that concern, and they can ask for a better explanation. They can ask for better supporting evidence. They could ask for it to be put in language that their colleagues can understand, that they can cut and paste.
Yeah, we always thought about it as the results provided by the application was information. And we're not precious about where someone consumes that information, but rather that they consume the information. So we'll put it or help to put that information into whatever system. Whereas now, because it has this wealth of knowledge, information, functionality that it's presenting up front, it's probably best to use the application in many ways. Get a trigger in your native systems that pushes you into the Senseye application. But as you said, you can also talk to it when you're not too sure about what to do. The function of being able to speak to your virtual online reliability engineer at any time of day and ask it any questions around correlations or patterns or what does this mean? What does my asset do in this environment? I'm new here. And teach me about a bridle motor or teach me about a fermenter in a pharmaceutical environment.
What I'd like to do is I've written down some use cases that I'd like to discuss. But let's just, before we get to that, let's just highlight what we think. Because, so candidly, we don't know how this platform is going to be used. We only launched it 2 weeks ago. ChatGPT and products like that are relatively new. As we said, the world is realizing there's more to it than poems and pictures. But we don't know what the usage is going to be. But we think the 3 things that we've focused on, which are kind of best guesstimate of the stuff that we can see, the low-hanging fruit problem solving, data literacy, as you've just described, knowledge, lost knowledge, which I'm going to ask you to explain in a second, and collaboration, the art of collaboration, or the destructive avoidance of collaboration. Just tell us a bit about lost knowledge and what that's all about in the context of GenAI.
Well, if I look at my experience when I was first starting out in my professional career, I wasn't titled this, but you could think of me like an apprentice, the person who carries the tools but not allowed to touch the tools. And as you get more responsible, you get more responsibility. But I was taught or trained theoretically. I was given practical experience in industries. However, the person who I was going round with, the trained engineer that I was apprenticing for essentially, had a huge amount of experiences that he was able to teach me, through interaction, through time, through being there and handing him the right tool and then having a conversation of why is this right? What is the right process here? What does this mean? You don't touch this, those kind of things. I learned so much more than you could find in any textbook. And if I had done my apprenticeship with someone different, I probably would have learned a completely different set of things. Some of them would be similar, but also a whole set of unique bits of knowledge and experience. And that is happening in pretty much all professions in industry, if you think about it, whether that is production or maintenance or reliability, condition, whatever it may be. So that lost knowledge is is being lost from decades upon decades upon decades of past and handed down face-to-face physical experiences and so on. And I'm sure people are quite sick of hearing this cliche, but it is true that people, especially in the mechanical engineering fields, are retiring. And there's not the same amount of influx as there will be going out.
Right.
So there is lost knowledge in that sense. People are retiring and they're taking their knowledge and experience and decades worth of hands-on activity in that factory away with them. So that's what we mean by lost knowledge.
Okay, so then the inference being that this platform whilst it's already got access to everything that they learned previously, can learn from those individuals as well, gather that knowledge. Okay. So the platform can be the apprentice in a way and learn and then become the expert.
Yes, but it can be like 1,000 apprentices, one for each member of your staff. Yeah, because it can learn from every single user that has access to the application. So every one of your maintenance staff can input, they can feedback in the form of maintenance events. Oh, you've highlighted signs of degradation. This is what I investigated. This is what I did to repair it. And here's my feedback on that. So it learns about that entire cycle for every asset.
And references it, and can reference it forever in natural language. That's so good. That's so good. It's such a paradigm shift for us, isn't it? Presentation of information, suddenly presentation of a case, augmented with every bit of information you could possibly need to draw on that's been presented to it. Okay, so that kind of, then before we jump onto the use cases, that's the lost knowledge, but there's also this collaboration and usage of existing data that you might not use normally, like manuals, etc., right?
Yeah, absolutely. So the way that we are thinking about it, or at least my team is thinking about it, is Senseye as a whole is around capturing knowledge or knowledge from data. So this is data coming from your OT environment, your IT environment, as well as the human interaction and documentation. Yeah. So that documentation can come in the form of user manuals, maintenance manuals, spare parts lists that you can easily reference because it's been loaded in. So now having in-depth knowledge that most engineers probably wouldn't have ever looked at a maintenance manual or user manual for an asset or machine because it's in the admin building in a cupboard somewhere. They've never needed to look at
plastic wrap around it. Yeah.
Yeah, exactly. But now if we have it in, it's easily referenced and they don't need to go and go through and sift through the manual, finding the relevant area, then finding the information they need. They can ask it the question and have that information easily referenced. Also, the spare parts list, for example. If you want to know what the part code is for a drive-in bearing, you ask the application and it pulls it up for you.
That's fantastic. So the things we're focusing on this year, maybe there's a change in a year, but it's this idea of resolving issues around the data nervous, people who don't want to be challenged by an interface. Collaboration. We've probably mentioned a bit. We do this in the use cases, but the fact it's multi-language, etc., as well. But access and actually making available all of that rich data that you've got that you don't currently use because it's just time. Who's going to do it? Who's going to go and find those manuals? And lost knowledge, collecting and consolidating and becoming the expert in all the things that it's exposed to by the maintenance team. I want to move over to this session should finish at 40 minutes past, which gives us 12 minutes. And if anybody has questions, please do start hammering them into the chat. I think there's a couple. Let me just have a look. I can't multitask. So let me focus on this, and you guys can put questions in if you want to ask questions. Let's have a look at some use cases. So the first one's about an OEM help desk. That's so specific. Let's talk about something less specific, more general. Okay. So let's talk about the example of a remote maintenance team. I think the example we gave is in the water industry, because you might have some difficult to reach locations with some pumps and things. But to talk about what are the ramifications of this step change from as was predictive PDM to now conversational PDM. What are the benefits to that remote team?
Well, if we use a maintenance team in the water industry as the example. So traditionally, even today, they will have within an environment or rather an area, they'll have tens of or hundreds of pumping stations, all in remote locations. There is typically little visibility of what is happening there unless there is a problem or something is stopped, and you can see that in the telemetry data. And then it requires someone to go out and first investigate it, see what it is. Maybe they can fix it if it's something small. If not, and they need parts and further resource, they have to go and plan that in and then go and fix it with the right parts and the right people. And that is time consuming. It's time consuming, costs a lot of money to work in that way. So the way that would then change is instead of having very little visibility of the condition of these pumping stations, you now have a centralized visibility. In one place, you can have a look, and with a very quick visual aid, you can see which pumping stations, which assets or machines in those pumping stations require your attention, and with quite a good degree of visibility, see what needs to happen on these assets. You can also collaborate with your team in one centralized conversation. You have this online reliability engineer to give you advice on what does an increase in motor current, temperature, and drive-in vibration mean? Or you can ask it and start to whittle your way down to the best form of repair that fits in line with what the data is telling you. And it will then store that knowledge. So it is around centralizing the view, having better control over your activities with better information, and being able to collaborate with a virtual reliability engineer as well as your teams, all in one space.
I'd be able to make better decisions, therefore, about where you go and when you go and if you go and what you need to take with you, etc.
And that's actually a very good point, is that Senseye isn't supposed to replace expert knowledge. It is supposed to scale your expertise and the skills that you have. You know, it's really a decision support tool. And we're trying to make your decision-making process as painless and as easy as possible, not about replacing those skills.
Well, there's much knowledge of evidence, and suddenly there's this sort of exponential explosion of the knowledge available to the platform to help you. Okay. One of the things we wanted to talk about was the use case of actually how it's used. So if you look at some of our clients taking the information out of the platform and into stand-ups, you know, how do you think? And some of our early adopters of this solution, you know, how do you envisage them using this in a stand-up, for example?
Yeah, I guess whenever I describe that point within our methodology, because we have a very structured approach on how to investigate, implement, and scale predictive maintenance, and usage and adoption is one of the phases or steps that we run through and we take into consideration. So when I describe this, I give two examples. One is one of our customers where every member of the maintenance team is responsible for bringing the information relevant to their area to their morning stand-ups. So they go around, they'll run through their normal stand-up activities, and then as part of each person's explanation of duties, responsibilities, actions for the day, they are bringing the information from Senseye. So the cases or notifications that were raised, what their plan of investigation is, how they aim to repair it, who do they need to inform. You know, we need to inform production and procurement because we need additional parts and what have you. So that's one example of how the application can be used. So everyone is responsible. The other way, which is on the complete opposite end, is to have a dedicated, what we would call a PDM champion. So this could be one person who is keen on technology within your maintenance department. It could be your maintenance planner. Essentially, the responsibility falls onto one person who can quickly go in, have a look at the updated to-do list in the form of cases, our form of notification, and then distribute this information to the maintenance team. Essentially, either approach works. The most important factor is is the information being used? Are the maintenance teams aware that they need to do investigations, that there is something impending that they would need to plan in and action out before it catastrophically fails? Yeah.
Okay. And I suspect this is an unfair addition to your answer, but in a way, we're such early adopters, we're so early in the phase of taking this and applying to the use case. We're going to be asking the market that question and asking about how it's facilitated. Yeah. There's some questions coming in, some from delegates on the call, and some I think via colleagues. But let's just go through them. Not all specifically about Gen AI, but that's okay because fundamentally this is a layer on top of a solution. Fundamentally, what we're trying to achieve hasn't changed. It's about better maintenance and about avoiding failure, and about making that easy and accessible to teams. So let me just read this one to you. So how do you collect data? How do you ensure that the data used is reliable and correct and not rubbish? I can remember we once had a colleague who used to love saying rubbish in and rubbish out.
Yes.
So how do you avoid the inclusion of rubbish in order to be able to predict decisions, or is that still based on human inputting the data to the model? Okay, so there's a whole bunch of things there that you can react to in reverse order: model, human, and rubbish.
First off, Senseye does not have pre-built machine learning models for asset types or pre-built machine learning models looking for specific types of failure. The application is designed to automatically build an understanding of normal behavior and highlight signs of abnormal behavior, which means that whatever we feed it, it will start to learn from, whether that's one parameter or measure or 100. And we have a very structured approach on how to investigate an environment to understand an asset's, what the asset is, its operational complexity, its operational interdependency. We also look to maintenance teams to get their expertise and experience around the maintenance they're conducting, how these assets are failing. Are there any special conditions that we need to know about in order to increase the reliability? And from there, we look at what data is available from the existing infrastructure. So this data can be coming from PLCs, drives, inverters, SCADA systems, dedicated condition monitoring systems, or solutions like vibration analysis, for example. And once we've done this, investigation of machine complexity, failure, data, we can look at the gaps and suggest to our customers what we recommend to install, if necessary. But we do have this process of investigation around the data quality. Now, we are not looking for raw high-frequency data. We're looking for process data, exactly taking the rubbish out while still giving key indicators within that. Yeah. And that's our delivery team can help our customers with processing on their end, so how to process the data correctly, or that can be done within a functionality we have in the app called Derived Measures. So we have a very structured approach on doing exactly that.
Yeah, and it's worth mentioning that these kind of projects are not based on big data. We're not looking for years of good data. Most of our good deployments are based on horrible data. And the art is to very rapidly and in a predictable and scalable way make sense of that rubbish data or that horrible data and turn it into good data so that you don't have to have expansive new deployments. Let's whistle through some because we've only got a couple of minutes left. Are there uses for Senseye beyond manufacturing? Absolutely. Anything that you can collect data on of this type that we've just been discussing that might show signs of degradation that could lead to failure, that can have an effect on whatever the function of that thing that you're looking at is, you can apply. In terms of how long does it take to implement, it can be anywhere between a month, 2 months, 3 months, depending on numbers of assets, size of project, starting point, whether you need to do architectural integration, etc., or not. And there's a question about someone being late to join. Can we explain Senseye? Jump onto the next session, which is starting in 2 minutes, when we will actually show you the platform, and I'll do a reminder at the beginning of I'll introduce Senseye at the beginning and then let John take us through the platform. The link for that is further up at the top of the page. It's above the picture of, no, it's not, it's just below the picture of me and John. There's a link. It says, stay with us and join the extended session here, join conversation. Just as a reminder, it's a team session, so when you come through, you'll be visible, but you'll be able to speak, ask questions, put your camera on, get involved in the discussion. And we'll carry on for as long as people want to carry on for. There's a question about a senior controls engineer transitioned from oil and gas to renewables, and now sees that there's a gap in the new industry. Come and speak to us, and we can talk about how to fill that gap. Okay, Jonathan, thank you for that. I hope that was useful content for people. I think these webinars should be light and breezy and chatty and inspire some ideas. If they have, use one of the 3 methods to come and speak to us. Either join the session in a minute, email us, or you have the option to do something with the link. Or think for a bit and then find someone from Siemens when you're ready and have a chat. There's one last question, but then I'm going to hang up. Does Senseye have a specific industry edge, manufacturing versus construction versus auto? No, we had to be, because of where we were as a startup, experts in predictive maintenance, and you can apply it to any vertical. Anywhere that there is data available, we can apply it. Being part of Siemens now means that we have domain expertise as well, but at the core of it, you can take us from any environment. Really lovely to spend some time speaking to John, and thank you everybody for attending. We're now going to jump over to the next conversation on Teams. Look forward to speaking to you again on another webinar. Don't hang up until you link through. Speak to you again. Bye.
Thanks. Bye.